Hello, I'm Shashank. This screencast is the continuation of Sudoku Part 1 that we did. Let me take you through the implementation of this Sudoku code for further methods. These test methods and cross methods are implementations that we did in the first part. The newly added methods here are parse grid methods, grid values, assign, eliminate, and displaying the grid. First, let us see what does grid value parse grid method does. If we try to print these values that are assigned from a dictionary dict as digits for s in squares, you can see that like for every value in the square for a1, a2, a3, all the available options from 1 to 9 are assigned to it. As you can see here, a1 is assigned with 1, 2, 3, 4, 5, 6, 7, 8, 9, a2, a3 similarly up to i9. Each and every element in the square is assigned 1 to 9 digits. Here in these for loops, if the digits are not assigned to the particular elements, then we are assigning the elements digits from 1 to 9. And here another method called assign method is involved. As you can see here, assign method is used for giving digits from 1 to 9. Here we came across another method called eliminate method. Like as you can see here, let me take here. Yes, as you can see here, eliminate method is used for eliminating the digits that are already present. Like if we assign 7 to a1, then we need not assign digit 7 in a2 because since it is a pair of a1, we need not assign 7 to it. As an example of this strategy, we can take this. And even the same is the case with the corresponding grids as well. The code, as you can see, the code implementation, eliminate method, if t not in value of s, return values, that means all the possible cases are eliminated from grids as well as units. If a square of s is reduced to one value d2, then eliminate d2 from the pairs. This part of the code is used for eliminating d2 from the pairs. The contradiction arises when we remove the last values. Hence, we handle the case called if length of value of s equal to 0, return false. Similarly, if a unit u is reduced to only one place for a value d, then we put it here. This part of the code is used for putting the values. Same is the implementation, like contradiction arises here also when no places are there for this value. Hence, we need to handle this case. We handle this by using if length of d places equal to 0, return false. And d can be only in one place in unit, and this can be done by assigning it there. This part of the implementation is done with the help of else if loop here, like if length of d places equal to 1, we are assigning the value here. Initially, we are passing the Sudoku grid that needs to be solved here, like 4 dot 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 8 dot 5. Here dot represents the empty space, or dot or 0 represents the empty space which needs to be solved. We have printed a Mars grid. Now let us check what does character and grid values consist. As you can see here, char's value is a list containing of all the Sudoku elements in the form of a character array. If we try to print the dictionary, let us see what happens. Like all these are returned in the form of dictionary. Like A1 is assigned with 4, A2 is assigned with dot. All these grid representation are converted into form of a dictionary. As explained previously, assign method is used for assigning values from 1 to 9 to each element. Now let us try to run the test cases as well. As you can see here, there are all test cases passed here. We did not completely solve this Sudoku because this is a complex Sudoku problem given to the system. In order to complete these problems, we need to complete our next modules as well. As you can see here, puzzle was completely solved by the rote application of strategies 1 and 2. Unfortunately, that will not always be the case. Here is an example of list order of puzzles like 4, 1, 6, 7, 9, 1, 2, 6, 7, 9 is given as input. It will be hard for computer to solve the problem. We'll see the implementation to solve this puzzle as well in the next modules.